Good afternoon, everyone. My name is Avani B K. Our project topic is detection and analysis of cancerous white blood copper cells from microscopic images using a blend of CNN. Our batch code is B12. We are doing this under the guidance of Professor Victor and reviewed by Professor Divya HN and Dr. Lokesh MR. My teammates are Prithvi GD, Sonali B S, and Likhitha D. I'm going to introduce and tell the motivation of our project. First, let's know what is cancer. Cancer is a group of diseases involving abnormal cell growth with the potential to invade to other parts of the body. Platelets, plasma, red blood cells, and white blood cells are the components of blood. Leukocytes or white blood cells produced in the bone marrow make up around 1% of the blood cells. Uncontrolled growth of these white blood cells leads to the birth of blood cancer. Leukemia, myeloma, and lymphoma are the three main types of blood cancer. The first one, acute lymphoblastic leukemia, is a type of cancer where the bone marrow forms too many lymphocytes. This leads to cancer. Multiple myeloma causes cancer cells to accumulate in bone marrow rather than releasing them into the bloodstream. According to 2019, when we take the count of death rate, approximately 1,500 people who died due to this disease contribute to 0.2% of the total deaths caused by cancer alone. The problems faced in the existing system are inconsistencies caused due to labor work of manual classification, the requirement of a skilled professional, the errors due to cells being indistinguishable when observed under a microscope, etc. Now moving on to motivation. In motivation, Prithvi, change the slide. Using machine learning algorithms, we can solve most of the problems that can be modeled appropriately, but it consumes a lot of time to give the result with greater accuracy in classifying cancerous and non-cancerous cells. So we will come up with a technique that reduces computational time by investigating the possibilities. The challenging task here is obtaining blood sample images and the computational time. Since only CNN technique is used earlier, we are trying to improve the existing model. As data plays an important role with every medical image analysis, our idea is to increase the data set to avoid overfitting the model. So finally, based on all these points, we will bring out a finished product that can be accessible to hemato-oncologist or the doctor in early diagnosis, so the survival rate increases. Next topic will be continued by Likhitha.
Good afternoon, all. We have selected our problem statement by reviewing these papers. IEEE paper about automatic detection of white blood cancer from bone marrow microscopic images using convolutional neural networks, which was published in 27th July 2020. Then, classification of acute lymphoblastic leukemia using deep learning, which was published on 2018, and acute lymphoblastic leukemia detection and classification of its subtypes using pre-trained deep convolutional neural networks, which was published on January 2018. Next, we will move on to the existing system. As we are proposing our project, keeping IEEE paper as reference paper, here the researchers are proposed their project with the following step. In first step, and proposed research described about the dataset, where the images of the blood cells is captured and add into a dataset, where the dataset is acquired from two different subsets. The first part of the dataset consists of images of patient having BLL, that is B linkage acute lymphoblastic leukemia, which having 90 images in the dataset. And the second part of the dataset consists of image of patient diagnosed with the multiple myeloma. Then the data augmentation step. The SN and AM dataset, which is a website for cancerous data, is first augmented by rotating the image and extracting the edges. Then the shuffled images are divided and into training and testing sets, and all the images are rotated by an angle of 90 degrees, as the model should be able to recognize the object present in any orientation. Then they proposed with feature selection step, where feature selection plays an crucial role in deep learning and massively affects the performance of the model. Therefore, the feature affecting the output are selected. The main key advantage of this process includes reduction in overfitting, as less redundant data eliminates the probability of prediction based on noise. After feature selection, next come up with the pre-processing of images, which includes the transform data obtained after feature selection is first normalized and then divided into training and testing sets after shuffling them. After that, the data set is divided into 75% for training and 25% for testing the model. After all these four steps, at last, proposed convolutional neural network and architecture step. In this proposed research, an optimized CNN model for classification of the type of cancer has been deployed. The researchers used CNN for analysis visual images. The CNN model is comprised of an input layer, an output layer, and multiple hidden layers. In this existing system, the proposed model takes an image as input and returns the type of cancer as output. There are some of the limitation in this existing system. Based on this limitation, we come up with the proposed system. It is further explained by my teammate Sonali B S. Thank you.
Good afternoon, everyone. My name is Sonali B S. As my teammate Likhitha explained about existing system and problem research, we have listed a few limitations and how to overcome it. And the first limitation is, as in the existing system, only 90 images in the dataset were used by the research as a dataset. As already known in the data description, there are only 90 images. Hence, we will try to improve on this by including more images to the dataset for more efficiency. And the second limitation is, in the base paper, researchers used only convolution neural network approach. To overcome it, we will investigate the possibility of using more classifiers to improve the accuracy. For more classifiers like Navy-based algorithm, decision tree, neural network, etc. And the third limitation is, the authors did not investigate the possibility of developing a mobile application. Hence, we are trying to develop a product that can be used by doctors and the clinicians. Now let us move on to the proposed system. In proposed system, it is a step-by-step procedure to get a type of cancer as an output. There are few steps: data set, data augmentation, feature selection, pre-processing or model training, classification of data, at last data collection. And the first step is data set. In the data set, the image of the blood sample has to be taken by the patient and applied to the data set. After taking the image of the blood sample from the patient, next move on to the data augmentation. In the data augmentation process, all the images are rotated by an angle of 90 degrees, as our model should be able to recognize the object present in any orientation. After the recognition of the object, next move on to the feature selection. In the feature selection, the features affecting the output are selected, and the main key advantage of this feature selection is reduction in overfitting, as less redundant data, and eliminates the probability of prediction based on noise. Based on noise, we eliminate the predictions. After the feature selection, pre-processing or model training. In the pre-processing or model training, the transform data is obtained. After feature selection is first normalized. And in the classification of data, the normalized data is then divided into training and testing sets after shuffling them. After shuffling them, for mobile proposed application, takes the image as an input and returns the type of cancer as an output in the data collection. The further information will be delivered by Prithviraj. Thank you.
Good afternoon, one and all. My name is Prithviraj D. So the objectives were defined with the help of our guide, Professor Victor. The first objective is to study the various machine learning approaches used in the detection of cancerous white blood cell, like SVM model or naive-Bayes. And the second objective is to compare the various performance of CNN models. So CNN models like LeNet, AlexNet, GoogleNet, or VGG16. And the third objective is to design a methodology to handle misclassification and class imbalance problem. So misclassification may occur due to the selection of which is not suitable for classification. When all classes, groups, or categories of variable have the same error rate or probability of being misclassified, then it is said to be misclassification. SVM can resolve this misclassification. Class imbalance refers to a classifier predictive model problem where the number of examples in the training data set for each class label is not balanced. That is where the class distribution is not equal or close to the equal and is instead based or skewed. This can be resolved using decision tree. And the last objective is to develop a mobile-based CDSS system. It means clinical decision support system. It is a health informative technology system that is designed to provide the physician or the health professionals with clinical decision system that is assisted with clinical decision making tasks. And the next slide is about the software used. The programming language is Python, and the operating system can be anything above Windows 7, and the database is SQLite and Google Firebase, and the IDE is PyCharm or Visual Studio or Jupyter Notebook. Thank you.
Prithviraj.
Yes, sir.
You are told that you need to implement, you are developing a clinical support system, a mobile app clinical support system, right?
Yes, sir. We'll try to, sir.
But I didn't find any tool regarding the mobile app development.
Sir, first we'll try to implement in the software, Python software, sir, in laptop, and then we'll try that, sir.
Python is a interpreter.
Yes, sir. For this, sir, laptop, in laptop.
See, if you are not yet confirmed about developing a mobile app, then you should not include that in your objective. Otherwise, when you present your project at the final stage, it will be considered as incomplete. Objectives are not achieved and they'll mark it as objectives are not achieved. So if you're not sure about that, you don't include it in your objective.
Okay.
Okay. And one more thing, throughout your presentation, you guys were speaking about overfitting. What do you mean by overfitting with respect to your project?
Ma'am, we have used limited data set, ma'am. So overfitting will occur, ma'am.
That's what I'm asking you. What do you mean by overfitting?
Ma'am, they have used just 90
said
images.
in order to
So
you said in order to avoid overfitting, you guys are developing some solution towards it, right?
Yes,
so
ma'am.
what do you mean by overfitting?
That only, ma'am. To give better accuracy, ma'am, we use with less data sets.
Ma'am, overfitting is a modeling error that occurs when a function is too closely fit to a limited set of a data points.
Google.
What is normalized feature selection? Feature selection normalized. You have written that word somewhere. They are normalizing the feature selection. What type of? Sonali explained, I think, that one.
Salient and to overcome it, sir, that is a normalization. To get the data into reasonable bounds, and we have to overcome it, sir, normalized.
No, you are talking about feature selection normalized.
Yes, sir.
What are the features?
The features which affects the output, which is useful for the output, we extract those features, sir.
In images, in blood images, you have selected some features.
Yes, sir.
What are those features? Have you identified those features in the paper? Blood image features. Can you tell me what you mean by feature selection?
Feature affecting the output and that are selected as a feature selection.
Sir, it helps to reduce the overfitting, sir. Feature selection.
No, I am talking about you are taking a blood sample feature.
Yes, sir.
Feature. What are the blood
Image.
sample features? Okay. So this and all you have to discuss with your guide. Okay. What do you mean by feature? Blood sample feature. You should not talk generally. You use a word called you are taking a blood sample. Blood sample will have some characteristics. Okay, I'm asking about the characteristics. What are the characteristics are there? So how do you represent the characteristics of blood samples? That is nothing but a feature. Okay. How do you select those characteristics? And in what, whether it is in a number, if it is a number means, or it's in the dimension means, what dimension? That is nothing but a feature selection. Let us assume that one of the characteristics of the blood images will be from 0 to 10, and some images will be 0 to 3 only. So you need to scale it for 0 to 10 only. Even though if it is a 3, it's having the value with 3, you need to scale with 0 to 1. So that is nothing but normalization. So you have to identify what are the different types of properties are present in the blood sample. That is nothing but a feature. And there are so many features are there. You need to select those things. So that is the main thing. From that only you are predicting. The main purpose is to detect, and you have to predict. No. So through that selection only you are deciding, and you have to identify the accuracy of your system compared to the existing system. Feature selection means that you have to discuss with your guide regarding that. Okay, then every slide should have some conclusion slide, so that you have to conclude telling that what you have done it in the presentation. So you have struggled for identifying the problem statement, and you have gone through different research papers, and then you have found out the existing state of the work in the particular problem statement, and then you have formulated that you have identified the gaps, and you have formulated your own problem statement. Like that, you should conclude. Every slide should have a conclude, and every slide should have a reference from where you have selected the paper. Like that. Yeah, other things and okay. Okay, these and all you have to discuss with your guide. Okay.
Okay,
You
sir.
have to show the PPT before presenting. Victor sir.
Okay, yes, sir. Yes, sir. Thank you so much, sir.
So I
for
have
the
given few inputs from my side.
Yes,
The other
yes,
things
sir.
and all you have to
Yeah,
take
thank you.
it. Okay, thank you, sir. Thank you.
Sure, sir. Sure. Thank you so much, sir. Yeah, that's why I don't want to give any insights now. Then I can discuss with them after the class as well. So yeah, any other suggestions, sir? So otherwise we wind up and let other people carry on.
Okay, sir. I'm leaving. Okay. From
Yeah,
my side,
sure.
no suggestions.
Yeah, okay, sir. Okay. Thank you. Okay, then Divya, ma'am.
Yeah, Victor. From
Okay,
my
ma'am.
end, no more questions. Problem statement looks interesting. So one thing I just wanted to tell is they should concentrate more a little bit on their presentation slides. They're putting the entire history on the slides. It should be of point. Yeah, only that
Okay,
thing I
ma'am.
just wanted to. Otherwise, you will take care of the rest of things. I know. Yeah. Okay.
Sure, ma'am.
Chalo.
Thank you, ma'am.
Bye.
Okay.
Thank you.
Yes,
Yeah,
guys.
yeah,
Let's give some 5 minutes break for other people also we join, and we might wind up now. Okay, thank you.
Yes, sir.
Prithvi?
Thank you.
Yeah. Okay. Bye.